One of the foundations of understanding many topics in mathematics is understanding what relations and functions are, and therefore also understanding what domain and range mean. First, what is a relation? Well, a relation is a mapping of one set of numbers to another. When we map the numbers in a relation, it may be totally obvious why these numbers go together. It may not. As for a function is a relation, but it's a relation where every x value has only one corresponding y value. So what this means is if I were to take a set of values, if we call them x and y, 1, 2, 3, a relation, I could have 1, 2, 3, 1, where this goes to 2, 4, 6, 8. In a function, I can't have the 1 and the 8 at the bottom, because for every x value, I can only map to one y value. So in a relation, you can have any numbers over here that map to any y values. Whereas in a function, if I say, for example, when I plug in 1, what y value do I get? If you have to say, well, it's either 2 or 8, that means it's not a function. It has to have a definitive, distinct answer. So again, some examples would be these two right here. So which one of these is a function? Which one is a relation? If you look carefully, you'll see both of them have something interesting going on where there are some numbers that are doubled up, or in the first case, tripled up. That doesn't matter. What matters is what's happening in this column. In these columns, you can only have each number once. Once you have a number twice, it is no longer a function. It can be a relation, which is totally a fine thing to have, but usually in math classes we deal with functions, so that's why we like to know the difference. So if you're looking at it pretty carefully, you can tell that because the 6 here shows up twice, this is a relation, whereas the second one is a function. And again, it is totally fine that both 1 and 6 map to 4. To make it easier to talk about, we can talk about domain and range. Those input values, or what we call the x values, that's your domain. The range are what we call our output values, and those are all your possible y values. So what we're used to is talking about functions in terms of x and y. So for example, f of x equals y. And when we talk about that f automatically means we're dealing with a function, where its domain is everything I'm able to plug in, and its range is everything that could possibly come out. So for example, you know a lot about y equals x squared typically. And one of the things you know about squaring is anytime you square a number, you always get a positive number. And so what happens on this is the domain, I can plug in any x value I want, whereas the range, we know that the only numbers that will ever come out of this are going to be numbers that are greater than or equal to 0. So we'll start with the basics though, because it's way easier to talk about domain originally before we start making it complicated. So again, domain are all the inputs, or what we would call the x values. So if you know anything about coordinates, you know these are your x values, which means that's what makes up your domain. So my domain would be the numbers 10, 6, 7, negative 8, and we can put set notation brackets around them to enclose it. And our range would be all those y values, 3, negative 2, 4, negative 9. One thing to notice is if we were to have another coordinate in here, let's say -8, 4, I wouldn't have to adjust my domain and range at all because the -8 is already taken care of here and the 4 is already taken care of here. And so I don't have to add another 4 or another -8 into my domain and range set. Can I? Sure, if I really wanted to, I could quick stick another 4 here, but it's redundant and you don't need it. This one looks more like the ones we did before. It's sort of a weird notation. You should notice that right here, because of this, that makes this a relation and not a function. So my domain is going to be the set of 1, 2, 3. My range is the set of 3, 4, 7. Ignore my really bad squiggles. Okay, so take a moment to write out what the domain and range are of this relation, and then also make a note of, is it a function or not? So while you're thinking about that, I'll start writing it down. Okay, so if you did it correctly, your domain should be -3, 0, 1, 5. Your range should be -4, -2, 0, 2. And whether it's a function or not, you can tell by this right here. If I say, when I plug in 0, what y value do I get out? You would have to say -2 and 0. That makes this not a function. Lastly, this is the kind that normally, if we talk about range, it's usually easier to do range looking at a graph. And these are the really basic graphs we do of relations at the very beginning, before we even learn what y equals x squared is and things like that. So it's a good idea to be able to understand domain and range just looking at a graph as well. So once again, figure out what your x values are for your domain, your y values for your range, and then tell me, is this a function or not? If you need to, I would pause right now because in about 1 second, I'm going to give the answers. And it's been about 1 second. So your domain are all your possible x values. So it looks like -1, 0, 1, and 4 are our x values, assuming these are our units. And the range, therefore, would be all those y values. So -1, -3, 0, and 2. And then, is it a function? Well, I paired them up literally in the order that they went in. So you can see there are no x values that have been doubled. What that would look like, if you're unsure, is it would look something like this. If there's another blue dot up here, then this would not be a function because of those 2 blue dots. Since that second blue dot is not there, and no one else has a weird second blue dot, that means this is a function. So hopefully that made sense about relations, functions, domain, and range to start off the fundamentals of mathematics.